Everyone, on this lesson I'm going to show you how to calculate equilibrium constant. We're going to look at this example, but the equilibrium constant, it's a value that you use to see if you are getting more product or more reactant. So, but in this lesson I'm just showing you how to calculate it. In this example they say 4 moles of nitrogen and 11 moles of hydrogen is injected into a 500 centimeter cube flask and is sealed at a temperature of 450 degrees Celsius. The equilibrium mixture, this is the reaction that they've given to you. Usually they'll give the equation balanced, is analyzed, and it is found that it contains 6 moles of ammonia where at equilibrium. When it reaches equilibrium, they find that there's 6 moles of ammonia. Calculate Kc at this temperature. So when you get a question like this, you go to that table that you were taught, that you write the reaction, the initial quantity, the change. In some textbooks they say produced, formed, or reacted, the change, and then the quantity at equilibrium and the equilibrium concentration. Okay, let's do that. Initial, it's what we started with. 4 moles of nitrogen and 11 moles of hydrogen is injected into a flask. So here's the formula. This is for nitrogen and this is for oxygen. Initial, we started with 4 moles of nitrogen and 11 moles of hydrogen. At the beginning, the reaction, when you start the reaction, you will not have ammonia. So you'll have 0 moles of ammonia. Because the reaction is starting to react, you don't have the product at that point, initially, at the beginning. And then the reaction happened at equilibrium. The mixture, yes, the reaction happening is analyzed, and it is found that it contains 6 moles of ammonia. So at equilibrium, here you have 6 moles of ammonia. You started with nothing at the beginning, and at equilibrium you have 6 moles. Now we're gonna go to change. Here, the formula, you look at the molar ratio, the numbers that are before that particular substance. You have a 1 here, you have a 3 here, you have a 2 there. What does it mean? It means 1 mole of nitrogen will react with 3 moles of hydrogen to form 2 moles of ammonia. So here, because it will react, it will reduce this. So 1 mole of it. This one, it will reduce with 3 moles of it. So you just write X, we'll find what X is. And then here, this will be formed. So it means you will add 2 moles of ammonia. Where do I get these numbers? From the balanced chemical equation. There's a 1 there, there's a 3 there, there's a 2. That's the molar ratio. 1 mole of this will react with 3 moles of that to form 2 moles of that. That is very important. Now, every time you'll get a column where you have all 3. You have that. You have initial, you have what had been changed, and you have your right. We're going to find the value of X. We started with 0, and then at equilibrium, no, this was formed 2x, and then at equilibrium we have 6, and then we solve for X. So you divide by 2, X is equals to 3. So it means we're gonna put that value in every X. 2 times 3 is 6. The change is 6. 3 times 3 is 9. And then X is just 3. What does it mean? It means you started with 4 moles of nitrogen, 3 reacted. How many do you have left at equilibrium? 1. You started with 11 moles of hydrogen, 9 reacted. How many moles do you have at equilibrium? 9, 10, 11, 8, 9, 10, 11. 2. So at equilibrium, you have 2. So this is the number of moles that you have at equilibrium. But you have to calculate the concentration. So this is the formula for concentration. Concentration is equal to number of moles over volume. Let's do that. Right, our volume is 500 centimeter cube. But when you look at the units for volume, no, for concentration is per decimeter cube. So you need to convert the centimeter cube to decimeter cube. How do you do that? You divide by 1,000. So for this one, our concentration number of moles is 1 divided by 5,000 divided by, it's 0.5. The concentration for the, let's calculate that one. 1 divided by 0.5, that will be 2. So it means the concentration of nitrogen is 2 decimeter cube. This one is 2 divided by 0.5. 2 divided by 0.5, it's 4. And this one, concentration is, number of moles is 6, and the volume is 0.5. 6 divided by 0.5, it's 12. So now we found the concentration. Then we can calculate the equilibrium constant Kc. Kc is equals to concentration of the product, which is N3. And then, no, concentration square bracket. This is for concentration. And the coefficient becomes here, divided by its product divided by reactant. Concentration of the reactant is nitrogen and oxygen. But the oxygen has a 3 there. The 3 becomes here. Then what is the concentration? It's 12 squared. When you write the values, not concentration anymore, you don't use square bracket. Divided by, for nitrogen was 2, and for hydrogen, no, this one was cubed. Okay, this one was squared and the hydrogen one was cubed. So you punch that in your calculator and then you find that it's 1,125. Kc doesn't have units. It's a scale that's showing you if you're going to get more product or less product. Okay, this is the end of our lesson. Thank you for watching.